Okay, this video is part 2 in a series of videos on how order derivatives. In part 1, we started doing examples. We did example number 1. In this example, we are going to look at how to derive an expression for the nth order derivative of a given function. So we've got 3 functions here. So we're going to get started with the first one. So in A we have 1 over x, which we're going to write in this form. So the idea with these type of questions is to work work out a few derivatives, maybe up to fourth order derivative, and then try to see whether we can spot any patterns that are developing. So okay, so in this case, for instance, the first order derivative then is going to be negative 1 x to the power negative 2. Then second order derivative is going to be negative 1 times negative 2 x to the power negative 3. Now the negatives work out to multiply to a positive, so it's going to be positive 1 times 2. Then third order derivative is going to be 1 times 2 times negative 3. It's going to be negative 1 times 2 times 3 x to the power negative 4. Then the fourth order derivative, there's going to be another negative, so this one is going to flip back to a positive x to the power negative 5. Maybe let me just do one last one. Fifth order derivative is now going to be negative 1 times 2 times 3 times 4 times 5 x to the power negative 6. All right, so now let's so from here we're going to make a generalization about the nth order derivative. Now we're going to do this, split it into smaller segments. For instance, if we start with the power, so we're going to need a comparison between the power and the order of differentiation. So for 1 it's negative 2, for 2 it's negative 3, for 3 it's negative 4, for 4 it's negative 5. So you can see that it's always 1 more than the order of differentiation and negative. So that means for n is going to be n plus 1. Then the next thing we're going to do is we're just going to look at the coefficient, these numbers here. Without the issue of the sign, we're going to sort out the sign separately. Okay, so for 5 we have got 1 times 2 times 3 times 4 times 5, which is 5 factorial. For 4 we've got 4 factorial. For 3 we've got 3 factorial. So that appears to suggest that for n we're going to have n factorial. Then the sign is flipping between plus and minus 1. So for n equals to 1, the sign is negative. For n equals to 2, the sign is positive here. For n equals to 3, the sign is negative. So the pattern that is developing here appears to say for odd n we want a negative. So that is achieved through powers of -1. If we raise -1 to power n, then this is going to achieve what this table is suggesting. So for instance, when n is 1, it's going to be -1 here. When n is 2, -1 squared is positive, -1 cubed is negative, etc. So this is like our full expression now. So we can write this like this, and since the power is negative, we can bring this to the denominator. So that's going to be the formula that gives us the nth order derivative. And then of course we can try out a few values here, and we should find that they give us each of these. For instance, if n is 2, so if n is 2, this thing is going to be -1 to the power 2 times 2 factorial over x to the power 2 plus 1. So -1 squared is positive, 2 factorial is 2, and then this is going to be x to the power 3. Now let's see if that agrees with the second order derivative. Yes, of course it does. All right, so that rounds off part A. So let's go now to part B. In part B, we've got y equal x over 1 minus x. So here we have a quotient, so we're going to have to use the quotient rule. So we're going to let u be equal to x. U prime is going to be 1. V will be the denominator. V prime is going to be -1. So the first order derivative is going to be u prime v minus uv prime all over v squared. U prime is 1, v is 1 minus x. Take away uv prime. This is u, and this is v prime, and then v squared is going to be that. So the numerator works out to 1 minus x plus x. So that's just 1 in the numerator. And then what I'm going to do is we're going to write this as 1 minus x to the power -2. Just like we did there, so that for the subsequent derivatives, instead of using the quotient rule, because there is no x term here, we're just going to use the chain rule. All right, so that means second order derivative is going to be -2 into 1 minus x, then subtract 1 here, so that gives us -3, and then multiply by the derivative of this. I'm going to write that this side, which is -1. And then of course this is going to be positive because we've got a negative and a negative there. So that is the expression we've got for second order derivative. Third order derivative is going to be 2 times -3, 1 minus x to the power -4. then the derivative of the inner function is -1. And then again, this becomes a positive. So again, notice that I am not working out these terms, just leaving them as they are, like we did here. And then in that case, it becomes easier to spot a pattern that is developing. Fourth order derivative is going to be 2 times 3 times -4, 1 minus x to the power -5 times -1, and then again this simply becomes a positive. So from that nth order derivative, this time it appears that all the derivatives are positive. Okay, so there's the first one, it's positive. Second one is positive. Third one is positive. Fourth one is positive. So as far as the sign is concerned, all of them are positive. Then next we look at the coefficient here. So that looks like 4 factorial. That looks like 3 factorial. And so that is going to be 2. So that means for the nth order derivative, we're going to have n factorial. And then the power, again, it's 1 more than the order of differentiation in each case, and negative, because you can see that we have got 3 and the -4 here, 4, -5. So for 5, it's going to be -6. And for n, it's going to be -n plus 1. So this thing is going to be n factorial, all divided by 1 minus x to the power n plus 1. All right, this at this point, we're going to give you an opportunity to have a go at C. So if you just want to pause the video, work through C, and then when you continue the video, you can compare with our answer. All right, we're now going to continue with part C. With C, we notice that the numerator does not involve an x term. So we are just going to bring 2x minus 1 squared to the numerator, and then we can differentiate this using the chain rule. So the first order derivative is going to be -2, and then 2x minus 1 to the power -3. Then the derivative of this is going to be 2. Okay, and then again, just going to leave these 2 terms as they are. I'm not going to combine them, because this one is coming from the power and this one is coming from the derivative of that. So, and then second order derivative, going to have -2 times -3, then 2x minus 1 is now going to be power -4. Then this side we're going to have 2 times another 2. Okay, and then we notice that we have got a product of 2 negatives here, so that means we can flip this sign to a plus. So that's going to be our second order derivative. Then we go to third order derivative. So we're going to have 2 times 3 times -4, 2x minus 1 to the power -5. Then this time we're going to have 2 times 2 times 2, which we can write like this, or we can write as 2 cubed. Yeah, perhaps let's write it as 2 cubed. So it's going to be 2 times 3 times 4, 2x minus 1 to the power negative 5, 2 to the power 3. Okay, then we're going to do one last one, and then we're going to try and see if we can spot some patterns that are developing here. Negative 5, 2x minus 1 to the power negative 6. This one is now going to be 2 to the power 4. Okay, and since we have 2 negatives here, then we can write this as 2 times 3 times 4 times 5, 2x minus 1 to the power negative 6, 2 to the power 4. So we now want to generalize this. So we're going to start by looking at the sign. The sign for the first derivative is negative. For the second derivative, it's positive. For the third derivative, it's negative. For the fourth derivative, it's positive. So it appears we have got a case similar to what we had in question number A, where we said then that is going to give us negative 1 to the power n. So we've got a similar situation here. So we're going to have that negative 1 to the power n. And then in terms of the numbers, just look at the numbers without the signs. That's fourth order derivative. This is 5 factorial. Notice that even though the 1 is not there, since multiplying by 1 does not alter anything, this is the same as 1 times 2. This is the same as 1 times 2 times 3. This is the same as negative 1 times 2 times 3 times 4. And that's the same as 1 times 2 times. So basically this is 5 factorial, this is 4 factorial. So for the fourth order derivative, we've got 5 factorial. For the third order derivative, we've got 4 factorial. For the second order derivative, we've got 3 factorial. So for the nth order derivative, we must have n plus 1 factorial. So that's what we're going to write here, n plus 1 factorial. Then we have got the power of 2x minus 1, which is always negative. For the fourth order derivative, it's 6. For the third order derivative, sorry, negative 6. For the third order derivative, it's negative 5. For the second order derivative, it's negative 4. For the first order derivative, it's negative 3. So it appears that the power is always 2 more than the derivative and negative. So that means for the nth order derivative, it's going to be n plus 2. And then lastly, the numbers on the right hand side. So it appears that they're always powers of 2, because they're coming from the derivative of this is always 2. For the first order derivative, it's 2 to the power 1. Second order derivative, it's 2 squared. For the third order derivative, it's 2 cubed. For the fourth order derivative, it's 2 to the power 4. So for the nth order derivative, it must be 2 to the power n. So this we can now combine or tidy up. This we're going to write in the denominator. So we're going to have negative 1 to the power n, 2 to the power n, n plus 1 factorial. Then in the denominator, we're going to have 2x minus 1 to the power n plus 2. Okay, notice that since these are both to the same power, we could optionally, this is an optional step, write this like that. Could just combine those two because they are to the same power. However, like I'm saying, this is an optional step. If you went as far as this one, then that's good enough pretty much for this type of problem. All right, thank you for watching. Hopefully this has been useful and exciting. Please do subscribe so that you can get notified whenever we post new material. Do like the videos as well, and post your comments in the comment section. Thank you.